Welcome to the second episode of our video tutorial series, where we guide you through the powerful features of the Building Generator tool for Unreal Engine 5. In this episode, we'll dive into advanced customization techniques. You'll learn how to easily modify existing presets using your own custom meshes, giving you the flexibility to create unique building styles tailored to your project's specific needs. If you haven't seen the first episode yet, we highly recommend checking it out. It covers the basics of the tool and includes helpful tips to get you started. Let's start with a fresh level. First, make sure that virtual texture support is enabled in your project settings. This ensures everything works smoothly with the Building Generator. To begin, simply drag and drop the BP_Building Generator blueprint into your level. That's all it takes to get started. Before diving into customization, let's take a quick look at the global override settings. These settings are especially useful if you want to apply certain parameters across all modules at once, instead of adjusting each one individually. Each override preset configures the building generator for a specific setup or mode, which can be really helpful in different scenarios. For example, selecting the random mode preset will set all mesh distribution settings across modules to random. Once you check the update box, the settings will be applied, and the building generator switches to random mode. Now, every module will be populated randomly, so each time you update the generator, you'll get a unique variation of the building's appearance. If you want to stop a specific module from switching meshes randomly, you can easily do that in the Details panel. Look for the distribution setting, select the module you want to adjust, and change its distribution type to either single or custom. This way, that part of the building will no longer be affected by random mesh switching, giving you more control and consistency where you need it. Keep in mind, if random mode is active and you move the building, mesh variations will be reassigned randomly. To keep your current setup, you can bake it into an editable blueprint. We'll show you how to do that in an upcoming episode, where we cover baking buildings into editable blueprint or static mesh. To turn off random mode, simply click on the Reset button. This returns the building generator to its default setup. Now let's focus on the Set Override Settings section. These settings let you override specific parameters across all modules, including materials, shadows, collisions, and culling distance. They're especially useful for performance optimization in your project. Simply select the parameters you want to override, then click the Override button in the Global Override settings. All selected changes will be applied instantly across every module. For example, let's override the culling distance, disable shadows and collision in just a few clicks. As you can see, once we apply the new culling distance, some modules are culled from view. But as you move closer, they begin to reappear based on the set distance. To reset everything back to default, click the small arrow on the right side of the menu, then hit Override again. This will restore all settings to their original state. Now let's move on to the next override preset, which is Customization Mode. When this mode is active, all module mesh distribution settings are set to custom. In this case, custom actually means sequential. All meshes are drawn from the mesh array in the exact order they're listed. This gives you full control over how and where each asset is placed. To make editing easier, we've added locator descriptors directly on the meshes. These markers appear automatically when you enter customization mode and help you quickly identify and adjust individual elements. These locators can be turned on or off at any time during building customization. Use the Off Locator button in the Global Override settings to hide them, and the On Locator button to bring them back whenever you need. Now let's demonstrate how to read a locator descriptor to quickly find and edit a specific element on the building. For example, take these doors. In the Details panel, type 2F right door. This will filter the settings for the exact element you want to modify. The locator descriptor also shows the mesh index number, which must match the number used in the mesh array you're editing. In this case, to open the door, we'll enable local transforms, set the mesh number in the array to 1, and then adjust the rotation angle. And just like that, the door is now open. Let's demonstrate the process again. This time on a small window. Start by typing 1F small window into the Details panel. This filters the settings for the small windows located on the first floor. Next, enable local transforms, then add a new mesh entry in the array and set its number to 2, matching the locator descriptor. Now, when you adjust the transform parameters, you'll see that you're editing this exact window. You can also remove the window from the distribution. To do that, enable the delete option, then add a delete mesh entry with the index number 2. And that's it, the window is now excluded from the building. With this approach, you can locate any mesh element distributed across the building, customize its transform parameters, or remove it entirely. We encourage you to experiment with these settings to get comfortable using them. Any existing element can be replaced, moved, or rotated, giving you full control over your building's design. And now that we've covered how to locate and modify individual building elements, we're ready to move on to a more advanced customization method, replacing preloaded presets with your own custom meshes to create unique, personalized buildings that match your project's style. Before you start replacing the existing mesh presets with your own custom meshes, we need to prepare them properly. Let's begin by looking at this schematic to better understand how the building generator works. The system uses parent modules. Think of them as the concrete foundation of the building. These parent meshes include distribution sockets placed at specific locations where child modules, like walls, sidewalks, or power poles, are spawned. To ensure your custom meshes work correctly with the generator, you'll need to add these sockets to your meshes. Now, let's jump into a quick demonstration on how to set that up. We'll start with a default building configuration. For this demonstration, we've created a few custom meshes, which are included in the project under the Custom Module folder, inside the Mesh directory. Of course, you're free to use any meshes you prefer. To begin customization, switch on Customization mode in the Global Override settings. This sets the mesh distribution to sequential mode and activates the locator descriptors, so we can clearly see which modules we're working with. For even better clarity, let's turn off all parts of the building except the first floor. This helps keep the screen clean and free of distractions. Now let's locate the folder with custom meshes and select the specific mesh we'd like to use as a replacement in the building generator. For this example, we'll replace a single wall module identified by the locator descriptor 1F wall with index number 0. To do this, we'll first locate the mesh preset inside the building generator. All mesh presets can be found in the customization section, organized by category. Since we're working with a wall, we'll look under Foundation Meshes, inside the 1F Walls mesh array. The index number of each preset matches the number shown in the locator, so if you replace just one mesh in the array, like index 0, the rest of the wall elements will stay exactly the same. As you can see, the wall has been replaced, but the windows are missing. This is because our custom wall mesh doesn't yet have the necessary distribution sockets. To figure out which sockets we need to add, let's take a look at the default wall preset. It's crucial that the pivot point of your custom mesh matches both the orientation and position of the pivot point on the default preset mesh to ensure everything aligns correctly. Now, let's open the Static Mesh Details panel and check which sockets are present on the default wall. You'll notice the default wall mesh contains several sockets, while our custom mesh currently has none. For example, if you want to spawn a window frame inside a wall opening, you just need to copy the socket name from the default mesh and add it to your custom mesh. In this case, the socket named SW_frame_1 is responsible for placing a small window frame. Once you add this socket to your custom wall mesh, the generator will automatically position the window frame correctly inside the opening. When you update the building generator blueprint, you'll notice that the small window frame has been added to the wall. Using the same approach, you can add additional sockets to place as many custom elements as you like. Keep in mind that you'll need to position these sockets manually, adjusting their locations and rotations to get the correct placement of each element. We recommend studying the preloaded meshes to see how their sockets are placed and oriented. This will help you understand how to properly position dependent elements on your custom meshes. To make things easier, we've also included pre-populated custom meshes with all the necessary sockets in this project. As you can see, once the sockets are correctly set up, replacing a mesh will automatically spawn all the extra modules in the right places. Now, let's remove all the default mesh presets and see what happens. If we leave only our custom mesh in the array, the building generator will fill every empty wall socket with that same custom mesh. However, as soon as you add additional meshes to the array, the generator will start populating the empty wall sockets in the exact order you've set in the mesh array. This means the order of meshes in the array directly controls the placement of each wall on the building, giving you complete control over the design of the building. You can change the order of meshes in the array at any time to experiment with different looks. You can also duplicate or add the same presets multiple times if it works for your design. It's completely up to your imagination. Once you're happy with the result, you can move on to the next building element to customize. For example, let's fix the building corners to make the walls look like a seamless brick wall. To do this, locate your custom corner mesh in the mesh folder, then find the default corner mesh presets in the mesh array. Simply delete the existing presets and replace them with your custom mesh. As you can see, the corners aren't aligned properly, and there are noticeable gaps between the walls. This issue is caused by the position of the sockets responsible for spawning the building corner meshes. Let's take a look at how we can fix this. These sockets are located on the foundation mesh presets. The main parent modules that hold all the crucial sockets for spawning child modules like walls, corners, and sidewalks. By adjusting the socket positions on these foundation meshes, you can correct the placement of these child modules. In our case, we've already made these adjustments on a custom foundation mesh preset, so we can simply replace the existing mesh, and the corners will automatically snap into the correct positions, creating a seamless brick wall. As we mentioned before, it all comes down to the correct placement of specific sockets on your custom meshes. Since custom meshes can vary in size and proportions, if you plan to use different wall dimensions, we recommend creating an entire custom modular kit. This way, you can replace all the preloaded presets starting from the foundation meshes, all the way up to the roof meshes, ensuring everything fits together seamlessly within the building generator system. Let's speed up the process so you can see the final result of the customized building. We quickly swap out the remaining default meshes with our custom ones, adjust the necessary sockets, and finalize the setup. This way, you'll get a clear look at how everything comes together once the entire building is fully customized with your own assets. To summarize, customizing buildings with your own meshes in the building generator requires careful setup of sockets, matching pivot points, and managing mesh arrays. By following the structure of the default presets, you can replace walls, corners, and other elements while maintaining proper alignment and functionality. Remember, if your custom meshes differ in size or layout, it's best to build a complete modular set to ensure everything connects smoothly. With these techniques, you gain full control over the final look and structure of your buildings. Thank you for watching this second episode video tutorial on the customization of the building generator tool. If you're seeking to elevate your environment and create stunning scenes, the building generator for Unreal Engine is an indispensable tool. You can find it on the Fab Marketplace, and the link is available in the video description. Thank you for watching, and don't forget to render your tale with us.